Welcome to The Explainer. Today, we are digging into a massive idea from the 17th century philosopher Gottfried Wilhelm Leibniz. And believe me, it has some surprisingly huge implications for us today. It's really a story about what makes something, well, itself. Okay, so to get this, you have to understand Leibniz's core metaphor for all of knowledge. He imagined philosophy as this giant tree. The branches are all the different sciences, physics, biology, all of it. But he said none of them could even exist without the roots. And for him, those roots, that was metaphysics. So to really understand this philosophical tree, we've got to start right where he did, down in the dirt, with the roots. We have to talk about what Leibniz saw as the very foundation of reality itself, metaphysics. For Leibniz, it was actually pretty straightforward. Before you can understand anything else, you first have to understand the basic rules of reality. You see, metaphysics wasn't just some abstract, navel-gazing exercise. To him, it was like the operating system for the entire universe, the source code that all of logic and science are built from. And this foundation is what leads us to one of his most famous, most powerful ideas, something he found deep down in those metaphysical roots. He was trying to find a totally logical way to define what makes any single thing unique. I know, that sounds super complicated, right? But the idea itself is actually incredibly simple. Just think of any two things. Now, if you could list out every single one of their properties, their size, shape, color, their exact location in space, their entire history, and if that list is completely identical for both, well, Leibniz says you're not actually looking at two things, you're just looking at the same thing twice. And here's what's really wild, how absolute Leibniz believed this rule was. This wasn't some suggestion or a good guideline. To him, it was a fundamental law baked into the very fabric of reality. There can't be two atoms, two planets, two anything that are perfectly 100% identical in every single way. Something somewhere has to be different. Now, this is the classic example that really makes it all click. For centuries, people looked up and thought the morning star and the evening star were two completely different things. But then astronomers figured it out. They realized they shared every single property, they were both the planet Venus, they had the same orbit, the same mass, and boom, Leibniz's principle kicks in. They aren't just similar, they are, by definition, one and the same object. So it seems like a perfect, unbreakable rule for identity, right? A really clean, logical way to sort the universe. But this beautiful, elegant idea ran headfirst into a major puzzle, one that would seriously change the course of philosophy. This question, which came from a later philosopher named Gottlob Frege, basically blew a hole in the side of Leibniz's principle. Just think about it for a second. If they're truly identical, then saying the morning star is the morning star should mean the exact same thing as the morning star is the evening star. But it doesn't, does it? The first statement is useless. Of course it is. The second statement, though, that was a genuine astronomical discovery. So how is that possible? And this puzzle caused a massive shift in philosophy. See, Leibniz was focused entirely on the things themselves, the actual objects out there in the world. But Frege came along and said, whoa, hold on, we can't just ignore the language we use to talk about those objects. The names morning star and evening star have different meanings, or what he called different senses, even though they point to the very same thing. Suddenly, the conversation wasn't just about reality anymore, it was about our representation of reality. And it wasn't just Frege. Other major thinkers started poking holes in this idea too. Bertrand Russell found that the principle could actually lead to contradictions in formal logic. And Leibniz himself got into this famous debate with a guy named Samuel Clarke, who basically asked, couldn't an all-powerful God, theoretically, create two atoms that were perfectly identical, just in different spots? And that really highlighted this growing tension between a neat and tidy metaphysical rule and the messy reality of the physical world. Okay, so let's zoom back out and talk about why this intellectual battle from the 17th century still matters so much. This wasn't just some squabble for the philosophy department. It fundamentally changed what philosophers thought their job even was. At the end of the day, this whole argument helped shape the next few centuries of thinking. The main focus expanded from just the world itself to the tools we use to understand it, our language, our logic. It really set the stage for everything from modern logic to computer science and the philosophy of language. So this whole journey, from a simple metaphor of a tree to this really complex philosophical puzzle, it captures a huge evolution in how we think. We start with this beautiful, logical rule for how the universe is supposed to be structured, but we end up finding that our very human systems of language and meaning add this whole other layer of complexity that the rule just can't handle on its own. And that leaves us with a pretty provocative final thought, one that brings Leibniz's old problem crashing right into the 21st century. I mean, when we can create a perfect digital copy of a file or a deepfake that's completely indistinguishable from a real person, Leibniz's no duplicates rule feels more relevant and more threatened than ever before. What properties truly define identity now? Thank you for joining this explainer.